Click the bell icon to get latest videos from Ekeeda.
Hello friends, let us solve one more question on design of NPDA. It is accepting the set of all strings of the form a raised to I, b raised to j, c raised to k and d raised to l such that I is equal to k or j is equal to l. Here we are using the power of non-deterministic PDA. One comparison will do comparison of A and C, the other will do comparison of B and D. So let us start with the construction. Taking up Q0 as the initial state, we will have two branches, one for the comparison of A and C, other for the comparison of B and D. First, let us do the comparison of A and C. Here, we will have two branches, one for the comparison of A and C, other for the comparison of B and D. Let us start with the first branch. Let us start with the construction of the first branch. Let's use the state Q1. This branch is used for the comparison of A and C. Over here, I'll push a 0. Over here, I'll push a 0 with every encounter of A, and I'll pop up that 0 with every encounter of C, while skipping B and D. So the transition would be on A, with Z as the top of the stack, push 0 onto the stack. Now we will have to repeat the transition for every A because we need to count the number of A's. For every A, with 0 as the top of the stack, push one more 0. Now we have to count the number of B's, but the actual count is not required. So we just have to make sure that at least one B is encountered. B with 0 as the top of the stack. Keep the 0 as it is. Let us take the new state as Q2. Now, whenever we are having a B, we just need to skip it. Every B with 0 as the top of the stack, keep the 0 as it is. That means we just have to ignore the B. Now we will start encountering C. So we will have a transition on C with 0 as the top of the stack, pop of the 0. What this will do? This will take out 0 one by one with every encounter of C. For that, we need to put a loop. Let us say the state is Q3. Writing the pop-off transition. C with 0 as the top of the stack, pop it off. Now we might encounter D's. D. When D is encountered, the top of the stack must be Z because the number of A's and C's are same. So all the zeros pushed while encountering A would be removed while encountering C. We'll keep the Z as it is. And we go to the final state. Let us say the final state is Q4. Over here, whatever number of D's are coming up, we can just ignore it. This completes one branch. Now we need to make one more branch to compare the number of B's and D's. While this is doing, we can skip the number of A's and B's. With this, we have completed the construction of one branch which compares the number of A's and C's. Similarly, we need to do construction of one more branch. For comparing number of B's and D's. Let us take the new state Q5. We will go to Q5 on encountering A. With Z as the top of the stack, keeping the Z as it is. Now, whatever number of A's are coming up, we'll skip it. Now we'll start encountering B's. B with Z as the top of the stack pushes 0. Now we need to count the number of B's. So with every B, we will push 1 0 onto the stack. Let us say Q6 is the state we are using. With every B, 0 as the top of the stack. Push one more 0. Now we will encounter C, which we can skip. C with 0 as the top of the stack. Keep the 0 as it is. Now we can skip all the C's which are coming up. Let us say Q7 is that state. With every C, 0 as the top of the stack. Keep the 0 as it is. Now we need to count all the D's. D with 0 as the top of the stack. We have to continuously pop it off. For all remaining D's, we need to put a loop. So we'll use one more new state. With every D, 0 as the top of the stack. Now, if the number of B's and D's are equal, then we need to move to the final state. So let us construct one final state. We will have a transition from state Q8 to state Q9. When the end of the string is achieved, with the top of the stack as Z, keeping the top as it is. This completes the construction of the required NPDA. Now let us see the components and let us run a string. Let us say M is the machine. We know the components are Q, sigma, tau, delta, Q0, Z, and F. The states used are Q0 to Q9. Q will contain Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8, and Q9. Sigma will contain A and B. Tau will contain 0 and Z. Now we need to write the transition delta. Delta from Q0 state on the input A with Z as the top of the stack. We have two transitions, one to state Q1, the other to state Q5. Q1 is pushing a 0 onto the stack, and Q5 keeping the Z as it is. Let us write other transitions as well. Delta of Q1 with A as the input and 0 as the top of the stack pushes one more 0. Q1 on B with 0 as the top of the stack will move to the state Q2, keeping the 0 as it is. Q2 on B with 0 as the top of the stack will skip the B. It will stay back to Q2, keeping the 0 as it is on the stack. From Q2, on encountering a C, it will have the transition to state Q3. Now, to match A and C, we will have a popping off operation. So delta of Q2 with C as the input symbol and 0 as the top of the stack. We will have state Q3 with a pop-off. From Q3, now I will compare A's and C's. So with every C, we will have a pop-off. On encountering a D, from state Q3, we will have a transition to state Q4. But now the top of the stack would be Z. State would be Q4, keeping the Z as it is. On state Q4, we will skip all the coming up Ds. It will be just Q4 with Z as the top of the stack. This complete all transition for the first branch. Now let's do the next one. Delta of Q5 on symbol A with Z as the top of the stack will stay back to Q5 only by keeping the top of the stack as it is. On encountering B, it will start counting by pushing a 0. So delta of Q5 with B and Z, we will have transition to the next state, which is Q6. Now I'll push 0, so it will be 0Z. On Q6, now we'll continuously keep on counting B's. How do we count? We will keep pushing zeros onto the stack. So delta of Q6 with B as the input and 0 as the top of the stack push one more 0. On encountering C, we need to skip them. So for that, we're using the state Q7. Delta of Q6 with C, 0 as the top of the stack. We'll have Q7, keeping 0 as it is. Next one would be delta. Next one is Q7 with C as the input symbol, 0 as the top of the stack. Transition to Q7 only, keeping 0 as it is. From Q7, on encountering a D with 0 as the top of the stack, we will start popping up. So we'll go to the next state, Q8. On Q8, we will start counting number of Ds and compare them with number of Bs. Now the final transition, delta of Q8 with empty string and Z as the top of the stack. We'll go to the final state, Q9, keep the Z as it is. So for this machine, we have defined Q, sigma, tau, delta. Q0 is the initial state, Z is the initial symbol on the stack. We need to write the final states, F. Over here we're using two final states, one is Q4, other is Q9. Having constructed the machine and defined all the components, let's try to run one string on this machine. Let us say we are running A, B. Having constructed the machine and defined all the components, now let us try to run one string. We are using ID, that is instantaneous description notation. String that we are taking up is AA followed by B followed by CC followed by D. AA, B, CC, D. Let us say we are using the first branch. The first transition would be Q0, initial state. The string haven't been visited yet, so it is AA followed by B, CC, and D. That's a complete string. Initially, the top of the stack would be Z. Now we will do the first transition. We need to check Q0 on A with Z. As we're using the first branch, we will have transition to Q1. Rest of the string is A, B, CC followed by D. Because of the first A, we will be pushing a 0 onto the stack. So this will be 0, Z. Let's see the next transition. Again, it will be Q1. As we have already visited A, now the string which is left out would be B followed by CC followed by D. Due to the second A, there would be one more 0 pushed onto the stack. So the stack content would be 0, 0, Z. Next transition would be Q1 on B with 0 as the top of the stack. It would be Q2. The string left out is CCD. Keeping 0 on the stack as it is. Now, let's do the next transition. We have state Q2 and we are seeing symbol C and top of the stack is 0. So the operation to be performed is popping off along with moving the transition to state, repeating Q2 on C with 0 as the top of the stack. We need to pop off the 0. Along with that, we have to move to the next state. So the next state is Q3. String left out is CD. And the stack content would be just 0 followed by Z. Next, we will have one more C. Along with that C, we will pop off one more 0, which is there on the stack. State would be Q3 only. String left out would be D. And stack will contain only Z because of popping off of 0. Last transition, Q3 on D with Z as the top of the stack. It will cause the machine to go to state Q4. The string to be visited is left now empty and keeping the stack as it is. You can see that at the end of the string, we are reaching to the state Q4, which is a final state, and hence this particular string is accepted. With this, we have constructed one more NPDA. We will see more questions in the coming up videos. Thank you for watching this video. Stay tuned to Ekeeda and do subscribe.